Hello, my name is Lenet-5. I'm the group leader of my group. Accompanying me are Zhi Lin and Kamarul Iman bin Kasman. So today we would like to talk about AI model training on Google Colab by implementing two-layer neural network, Lenet and AlexNet AI models. So let's start it off, shall we? Demonstration part.
We'll be demonstrating the task one of the group project, which is using MNIST dataset with second layer neural network and the Lenet-5 model. So for this demonstration, I will be using the MNIST numbers dataset right here, but I can also use fashion MNIST dataset right here. So here is the dataset, and for the model, I will be using the Lenet-5 model right here, and I already trained my model, and let's test it. So for the testing part, we have to draw the number on this canvas right here. So let's try it. So the AI model has detected that this is a class 3, which is the correct class.
I'm Zhi Lin. I'll be demonstrating task 2, which is using CIFAR-10 as a dataset. This dataset having 10 classes. First, we try with two-layer neural network first. With this, we have a test accuracy of 40%. And let's try upload a cat photo and let's see how it works out. It recognizes it as class 7, which is a horse. In this case is incorrect. As the test accuracy is just 40%, it is expected. The same CIFAR-10 dataset, we ran again using Lenet-5, and we got the test accuracy of 69, which is better than the two-layer neural network. Here I'm gonna upload a cat photo and see how it's work out. The thing is, it's a class 3, which is a cat. In this case, is correct.
So now I would like to demonstrate task 3 on on the results. So I have simulated this model, AlexNet model earlier, and it has come up with if I'm not mistaken, yeah, it's 72% test accuracy. And then so the thing is that if this is available, TensorBoard display is available, I'll have displayed it. But the thing is, every time we try to run it, Google Colab will always crash. So I rather demonstrate it right away. So I have tested this model earlier with a photo of a cat, but let's try with another photo, perhaps a dog. Alright, so okay, so now it's done. Now let's test it out. What does the AI think? Now the AI think it might be a dog. Yes, so that's correct. So it's a dog. As you can see, I uploaded a photo of a Labrador dog. There we go. We found out that this model has been sufficiently trained to classify at least 3 categories correctly.
Task 1, the comparison of the training, validation, and test loss and accuracy between two-layer neural network and the Lenet-5 model. So this here is the two-layer neural network, and the test loss for the two-layer neural network is 0.123, while the test accuracy of this neural network is 0.966. So next we move on to the Lenet-5. The test loss of the Lenet-5 model is 0.0443, which is much better compared to the two-layer neural network, and the accuracy is also much better than the two-layer neural network, which is 0.9878. So next, moving on to the comparison between the training and validation accuracy and loss between the two-layer network and Lenet-5. So from the accuracy graph here, the red line here represents the Lenet-5, while the orange line here represents the second layer neural network training. So the Lenet-5 training accuracy is much higher compared to the two-layer neural network training accuracy. So the Lenet-5 model is better in that. And the light blue here is the Lenet-5 validation, while the dark blue is the two-layer neural network validation. And in the validation part, validation accuracy part, is Lenet-5 also much better than the two-layer neural network. So moving on to the loss graph right here. So the color is the same as before. So for the Lenet-5 training loss, so the Lenet-5 training loss has a much lower value compared to the two-layer neural network training loss, which is the lower the loss, the better is the model. As for the validation loss, the Lenet-5 also has a lower value compared to the two-layer neural network validation loss.
Here is the result for task 2, which is using CIFAR-10 dataset, training on a two-layer neural network training model. And with this training model, we got an accuracy of 41% with 10 epoch. Let's compare it with Lenet-5. With this Lenet-5 training model on the same CIFAR-10 dataset, we got a much higher test accuracy this time with 68% comparing to the two-layer neural network, which only 41%. Let's compare two-layer neural network and Lenet-5 side by side. Both are trained with CIFAR-10 dataset. Orange line is training phase and blue line is validation phase. As you can see, the accuracy for two-layer neural network on the training phase is not that good. It's only set around 45%. And on the validation phase, it's not that good either. It's only set around 43%. Let's compare with the accuracy of Lenet-5. On the training phase, the accuracy is pretty good, which is set around almost 1, which is a good thing. But when we had in validation phase, it's only have accuracy of 70%, which is not that good. Let's compare the losses. For two-layer neural network, the losses for training is around 1.45. It's not a good thing. And on the validation phase, the losses is set around 1.5. It's not pretty either. Let's compare with the Lenet-5. The losses for training phase set around almost 0, which is a good thing. But when we test with the validation phase, the losses keep going up, which means the Lenet-5 does not fit for CIFAR-10 model, and neither two-layer neural network fit for CIFAR-10 dataset. Even for the 1 minute increase in the training time for Lenet-5 compared with the two-layer neural network, I would say the accuracy is getting higher, but both are not fit for CIFAR-10 dataset. So let's implement something more, have a more layer, so that it can train more better. So in this case, it will be AlexNet. So I'll pass to Andy.
Hi, I'm back. So now I will be talking about task 3, which is which is using AlexNet with CIFAR-10. Sorry. So what is AlexNet? AlexNet is basically an AI model designed to classify high-resolution image in ImageNet during one of the competition under ImageNet. As you can see, it's back in 2010. And then we would like to, so basically, since it is designed for high-resolution images, it has 11 by 11 filter. However, it can be adjusted accordingly. So the main improvement in AlexNet is that it is designed to prevent overfitting by introducing data augmentation and dropout. Also, it uses ReLU function instead of arctan and sigma function, which means it is much faster and it doesn't require input normalization. However, we will require Docker normalization method to aid with model generalization. And then the architecture itself, AlexNet itself, is designed for parallel computation, basically using more GPU at one time. And then it has overlapping pooling, which means that it is harder to overfit by using this model. So this is the general architecture of AlexNet. And this is, by breaking that down into more tabulated form. And then let's take a look on the snippet. As you can see that we began with convolution layer, which is the input layer, with 64 filter size, if I'm not mistaken here. And then we go to 32, 64, 32, 16. So this is the hyperparameter we have chosen by trial and error so that we get the most optimized output. So this is what we get when running the code in Google Colab. So as you can see, AlexNet contains a lot of hyperparameters. So this means that selecting adequate and robust sets of hyperparameters can be very, very daunting. So most of the time, it is based on intuition and trial and error. It's something that we learn as we go. So the big question is that how does AlexNet compare in terms of performance with two-layer neural network and Lenet-5 AI model? So as you can see that we have higher accuracy, lower loss, higher validation accuracy, and lower validation loss on the final epoch of this of AlexNet's model training. And then when we run through the testing, right, we get lower test loss and higher test accuracy from AlexNet model. So yeah, we see that we have lower test loss and higher test accuracy in comparison with those other two. These are the numbers, of course, respectively. And how does this compare? Yeah, we have it is included here what those numbers exactly are. And yes, there's another high accuracy means it's better, lower losses also means it's better. So the conclusion is that firstly, we have successfully trained a few AI models. We don't exactly start from the scratch in designing it, but rather we use existing code and then modify a few things here and there. And we understood the importance of the hyperparameter optimization in AI model training, as indicated in earlier part of this presentation. And lastly, we found out that there are limitations with Google Colab. Some of it was regarding about the compute capability or allocate compute, since, like I said earlier in class 3, we found out that TensorBoard crashed whenever we tried to run that specific block. So that's because we ran out of RAM. So this can be something that one might consider before going for more complex AI models. But in the end of the day, objectives of the experiments were met. Thank you.